Hello, sir. Today I'm going to take you through my part 2 for PROG7312. So for this part, I decided to use a stack, dictionary, and hash set, and then we also use a generic list. So I'll go through the code, and then I'll show you the UI and the functionality. So let's start off with the stack. So this is my own stack. As you can see, I had to call it EP stack because you can't use stack again because it's a C# class. And then it inherits the I enumerable, so we can iterate through the elements, basically. So you can loop through. Then we declare a list, generic list of elements, and then we have a push method where we just add the data the user wants to the list. So we just call the .add method for the list and just add it to the list. So that's what push does. Then we have pop, which will remove the element off the stack, which will be the element at the top of the stack, basically. And then if it's empty, it will throw an exception. And then we have peek, which will show the last element. It will return the last element. And we have an isEmpty method, so we just check. Basically, this way I use, so like over here, I call this method, which is this, just to check if the stack is empty. And then here's the I enumerator, so we can just iterate through the elements. Okay, and then let's go through the dictionary. So same thing for the dictionary. It inherits the I enumerable, so you can iterate through. We declare a array of linked list called buckets, which is used to handle collisions. Then we have a private variable count, which is basically the number of key value pairs stored. And then we have a private const float load factor of 0.785. So basically that's the threshold to resize the dictionary. So like when it's 75% full, then it will resize. Then we have a constructor, which will create a bucket array and then have an initial capacity of 16. And there's our get bucket index method of type int. So you have to return an integer, which will basically assign a hash code to the bucket index. So in this int hash, we call the get hash code method, which is a C# method that does hashing for you. So we do that, hash the thing, and then store it in the int hash a variable. And then we pass it into the math.abs because it can sometimes return a negative, and that's not allowed. So it basically makes it positive always for you. So we return it as that. Then we have our add method. So it just over here we just check if we have to resize when the element is added, basically. And then we just check for duplicate keys, and then we add the new key value pair to the bucket. So that's the add method, and then the get method, we just get the value by the key, basically. Yeah, if you want me to, I don't think I have to go through line by line code. And then we just have a check if a key exists, contains key method. So it's a true or false. So it's just, yeah. And then we have a remove a key value pair by a key. So it will take a key and then remove the element if it exists. And then here's our resize method that will be called if the thing is 75% full. So this will be called to make it bigger, the data structure. So we'll just create a new bucket array and then double the size. And then we have to rehash all the existing data into the new bucket array, basically. And then we just replace the old bucket with the new bucket that's resized. And then we just have our enumerator again, which just helps us iterate through. And then here's the hash set. Similar to the dictionary, we have an array of linked lists, buckets, or buckets. Same thing, we have a count, number of items in the set. Then we have the resize threshold again also. Then we have a constructor again, same thing, bucket array with an initial capacity of 16. And then we also assign a hash code to the bucket index, and then we call the C# built-in get hash code again. And then same thing we use the math.abs, so we don't get any negatives. or it'll take the negative and make it a positive. And then we have an add method. It contains method, and then a resize method, which will be called when it's like getting full 75% full. And then we just have our I enumerator, same thing again. And I guess we can start with the implementation. So I have a class called evented announcement, takes title, category, description, date, getters and setters, and then a constructor. So yeah, it starts. So this string method called normalize key is just basically for our searches. So like to clean it out. So like maybe if the user has a caps lock or types in all caps lock by mistake, or yeah, just little things. It just makes it all standardized, I guess. Yeah, so you get rid of white spaces or what, extra white spaces. Then as you can see here, we declare my own stack called the EB stack, and call it event stack of type evented announcement class. Then we do the same. My own dictionary has been declared. We have it twice here. One for called events dictionary, and then the other one's title index. Then we have my own hash set also. We have 3 of them. One is just for categories alone, dates alone, and then the other one's a mix of category and date. And then we use my dictionary and list for my recommendation feature. So we have 4 dictionaries, one's for the category search counts, others for the title search counts, and then one's for user search history and others for search combination. And then we just have a list of type string for called all categories. And then in here, I just added dummy data to my stack. So as you can see, I call the .push method, which is from my stack. As you can see, I call it, I use it, I add all this dummy data inside of it. And then we just loop and do the same for our hash set, add it all to the hash set and dictionary. So it's more efficient instead of just having to do it always on. So as you can see for the events dictionary, call the .add method, and same for the hash set. As you can see here, for the hash sets, category set, .add, just call all of that again. What else? Okay, now this is the controller to get. When you get onto the page, it will take in either a string queue, which is basically the search functionality, string category, which is a filter by category, and string date, which is filter by date. Basically, that's what it takes in parameter-wise. And then we have a view back bit to basically display all our items in the stack to the front end. And then we just have a list of event and announcements called filtered results, which stores filtered results. Then we have a normalized query string, which basically calls our method above as I showed you. I have the same for category and date, just cleaning out the data again. So it's all the same. Then we use the dictionary to filter by title, just loop through it. You can filter by title, and then again filter by categories in the hash set, and then filter by date, which also is used in the hash set. So, and then we call our record search analytics method, which I'll go through in a bit, and our generate recommendations method also. We call it here. I'll go through that now. So this is the record search analytics method of type void. So basically, it just records the user's searches, what they've done, so we can generate their recommendations. So it takes in a string title query, string category, string date, and then we just this is just for logging to see in the console what's happening. So we basically just track category searches, and then we remove old entries and add new ones with an incremented count. So we just remove, add, basically, and increment the count. And then just more debugging stuff to see in the console. Then we do the same for title searches. If they search by title, we do the same for a combination of category and date filtering. Basically, the add, dot remove, and increment by count. We do all the exact same. Then here's our generate recommendations based on user searches. So it's a private method that needs to return a list called generate recommendations. Takes search title, search category, search date also. Then we just have a list of recommendations, added titles, which is to prevent duplicates, and then category scores, which scores each category based on how many times they search for it. Then we have a try and catch block for if any errors occur. Then we'll just calculate popularity scores for each category based on their searches. So we'll just loop through all categories, and then we give a base score of 1 for all categories. And then we also, so we can give, so here we give a big bonus from search counts, and we just multiply by 100, and then log again. That's just logging. And then we can also give a small bonus so recommendations aren't like repetitive. You don't get the same things over and over again. So just a little bonus to keep things changing, I guess. Then we just sort categories based by the highest first over here in this lambda expression. So we order by descending scored. Then just log out again, log. Then we add events from the top scored categories, loop through it, and then add events from each category. What else? Then we just stop if we have more than 4 recommendations, we stop. If we need more recommendations, this will happen. So if it's less than 4. And then this is if no search, so like if the user didn't have any search history, it just shows like a mix of all different types of categories. So like on page arrival, they wouldn't have any search history, so this will happen first. So it'll just be a mix of all the categories shown. And then we return a recommendations, the recommendations list, because the method requires a list to be returned. So I will run the application now. So here's the homepage. As you can see, very nice UI. All the pages are in the middle of the nav bar. As you can see, you have this little bounce to it, which is nice. And then this is coming soon. This is our new feature. This is our homepage, our main menu. Then there's a report issues for part 1 as shown before. And here's our page, our local events and announcements. As you can see, there's a nice recommendation UI, little bounce. You can hover on it and this shows to get more details. So I'll also, before we start, let me just show you first. So as you can see now, the events and announcements are shown from the stack. So all this is shown from the stack. Now, if we search by potholes, we should only get this potholes in Benoni, potholes in Braamfontein. This will be using our dictionary. As you can see, there's that. And then we can search by, let's see, we only want sanitation. So this will use our hash set. Such, as you can see, garbage collection delayed. And then let's do by date. So let's do October the 4th. Let's do September the 12th. So I'll click here, September the 12th, I'm pretty sure, search. And as you can see, we only get results for September the 12th. And then let me show you the recommendation. So I'll just clear this. So let's say the user searches a lot of roads or let's say utilities. So as you can see, utilities are here in the middle. Let's say they do a lot of utilities. We search, okay, nice. Search, and now utilities are at the top because they searched us the most. And then we can also, like, let's say we do a lot of, they decide to search a lot by roads. So I'll just span roads quickly. And as you can see now, another road's been added. But still utilities is favorite at the moment. And now roads is the most popular category, which is now at the top of our recommendation, basically. So that's it pretty much. I'll just show you how the UI looks, so it can also cater to different, for mobile, different screen sizes. So I'll show you now. So I'll make it mobile quickly. So here's, I'll just make it a bit bigger. So as you can see, here's mobile, also looks really good, very usable. And then here's the home page also for mobile screen. So it does work for all screen types, which is very nice. And then, yeah, I can go to the other pages also with this drop down nav. And as you can see, it looks very good on all screen sizes. Thank you. So